Today, we're going to make a lighting model that is as cheap and fast to render as possible. Let's go. So we're in the middle of a series of videos on creating your own custom lighting model. Last week, we converted this sample Unity scene to use it. So far, this is the lighting model that we've built. It's a pretty good approximation of the lighting model that the engine already does, except it's using blend specular, which is a little bit more simple. If you haven't seen the previous videos in the series, I'll link the playlist down below so that you can catch up. One of the key reasons for customizing the lighting model is that you want to make it run faster. If you're making a game for a low-end mobile phone or a VR headset, those devices are pretty weak on GPU power. So we need to find a way to reduce the math that we're asking them to do. So in this video, we're going to make our lighting model as simple as possible so it will run faster on weaker hardware. So in order to do that, we're going to take the lighting model that we've created already, and let's come down here to our project window, and we'll come here to lighting. Here's our subgraph, simple lighting 2, and I'm just going to Control C and Control V to make a copy of that. And instead of simple lighting, we're going to call this basic lighting. Then we'll open up basic lighting, and we're just going to start tearing into it. It looks like we have some leftover nodes up here from when we were working on our Fong specular, so I'm just going to delete those. We definitely don't need them. But let's zoom in and take a closer look at what we're doing here. So we're calculating reflectance, diffuse, specular, and ambient. And then we're also doing the math for additional lights here. Then we're doing a little bit of metalness calculation and some fog here at the end. So the idea of making this cheaper is we want to decide what features can we get rid of, can we sacrifice to make this run as fast as possible. And so the things that I'm going to get rid of are specular, reflections, fog, some other things like that. So let's open up our blackboard, and we're going to get rid of metallic as well. So I'm going to delete metallic, the metallic input, and I'm going to delete the smoothness input. So now we're just left with base color, normal, and ambient occlusion. Okay, so now let's get rid of a couple of these nodes in our graph. We can get rid of this adjust smoothness node because we don't have any smoothness. We're going to get rid of reflectance. And we're going to get rid of the fog as well. Now, obviously, if these are features that you need, any of these individual features you can keep as you're customizing the lighting model yourself. The other thing that I'm going to get rid of is specular. And so we're just going to be left with diffuse and our ambient occlusion. And here we want to get rid of this metalness calculation. Okay, so we have our ambient occlusion, we have our diffuse, and then we're calculating things for additional lights. Now, there are two of these nodes that we need to simplify just in order to make them run faster. We need to simplify our ambient, and we also need to simplify our additional lights. So let's simplify ambient first. Let's save what we've done so far. I'm going to come out here, and this is our ambient folder. We've got a couple of different ambient light models. I'm going to pick ambient simple SSAO that we've created previously. And again, I'm just going to copy and paste it. And I'm going to name this one ambient basic. Now, the nice thing about this is that as we're going along working on custom lighting models, we're building up individual components. So right now I have 3 different ambient components and then this SSAO component that goes inside the other one. But These are components that we can mix and match. So in the future, if I want to make a different lighting model, I can pick which ambient component I want based on the features that I need. All right, let's go ahead and open up Ambient Basic, and we can just delete everything out of here that we don't need. So we don't need this specular ambient, that's the reflections. So I'm going to get rid of these. And we don't need anything that does metal, so I'm going to get rid of that. Basically, all we need is this one node here that samples our global illumination. That's the only ambient that we need. So we have our normals coming in, and we sample our global illumination. And then we're going to multiply that by our ambient occlusion. And that's pretty much it. So we're just going to wire that out. And now we can get rid of the screen space ambient occlusion here. And this minimum node. And we don't really need a group for this since there's... Whoops. We don't really need a group for this since there's so little going on here. And now we just need to clean up our inputs and our outputs. So for our outputs, we don't need our direct AO here because we don't have screen space ambient occlusion. So I'm just going to delete that. And for our inputs, we only need normal and ambient occlusion. So I can get rid of base color, and I can get rid of metallic, and I can get rid of smoothness and reflectance. So we're just left with normal world space and ambient occlusion. Okay, so there is our simplified version of specular. And like I said, all we're doing is sampling the global illumination and then using that directly. So we don't have any reflections, and we don't have any reflectance. It's just a very simple graph that's doing as little as we can. Okay, so if we switch back to our lighting basic here, we need to swap this out. So I will search for ambient basic. And for ambient basic, we'll wire in our normals and our ambient occlusion. And then we'll connect up the result of that. And now we can delete the ambient simple SSAO node. So we'll just put our ambient basic node here. Okay, the last block that we need to simplify is our additional lights block. So let's switch back to our project here. Go to our additional lights folder, and we'll just copy and paste that. And we're going to call this additional lights basic. And we'll open this up. And for our additional lights basic inputs in our blackboard here, we're going to need our main light diffuse coming in, our main light color coming in, but we're not going to be calculating specular. So I can get rid of specular, and I can get rid of specular power because we're not going to be using those. Okay, and then for our custom function here, again, we can get rid of specular power, and we can get rid of main specular. And then for our outputs, we can get rid of specular here as well, because we're only going to be outputting the diffuse and the color. And then for the outputs of our subgraph itself, we can also get rid of specular. So we're just outputting diffuse and color. And now we need to actually edit the code that we're doing in our custom function. So let's change the name of our custom function. So it's basic. And then we need to edit our code here as well. So what I'm going to do, we've already gone over this code in previous tutorials. So I'm not going to get into exactly what this code is doing. But what I'm going to do is copy and paste this code from a shader that I already have, and I will put this, I will put the text of the code down in the description so you can copy and paste it as well. But basically what we're doing is just going through this and getting rid of anything that we don't need. So here we're calculating specular, and here we're calculating light cookies and all of that stuff. So we're just getting rid of features that we can sacrifice in order to get better performance. So I'm just going to paste this in here. And again, I'll put this code down in the description so that you can see it as well. And then you can just copy and paste it as well. So that is our additional lights basic node. So let's go ahead and jump back to our basic lighting, and we need to stick our additional lights basic here. So there's our additional lights basic node, and we need to wire in our diffuse Lambert, our main light color, and our normal. And then for our output, we can output our diffuse light and our color. And then we can get rid of this additional lights node here, and we're using this simplified additional lights node instead. All right, so now we just need to tie everything here together at the end, and I think what I have is maybe just a little bit too complicated. So let's simplify some of this. I'm going to take our diffuse output from our additional lights node, and we're going to multiply it by the color. And then we're going to add in our ambient. And then we're going to multiply all of that by our base color. And that is going to be our result. So we're just doing this lighting as simple and basic as we can. And so let's just clean up our graph here. And you can see that we've taken our lighting model that used to be fairly complicated, and we've just streamlined it down to just the bare essentials. So we're calculating diffuse lighting for the main light. We're calculating diffuse lighting for the additional lights. We're sampling our global illumination and then combining all those together. And that's pretty much it. So let's save this, and we'll swap it out for the lighting model that we've been using. So we'll switch back here to our master lit shader. Here's the tune shader lighting that we created previously. Here's our simple lighting. And if we come in here, here is our basic lighting that we just created. So we have a normal, or we have a base color input, we have a normal input, and ambient occlusion. So let's go ahead and wire these up. There's our base color. There's our normal, and there's our ambient occlusion. And so there's our basic lighting that we've hooked up. So now, instead of simple lighting 2, we're going to replace that with basic lighting, and we'll save it. And now we can switch back to our sample scene and see the result. So here's our sample scene. It's running our base lighting. We've removed reflections. We've removed screen space ambient occlusion. We've removed specular highlights. We've removed light cookies. So there are a lot of features missing from the scene. But what you can see is that the scene basically still has the same character as it did before. You know, we do kind of miss some of the things, like we were using the light cookies to get really cool looking shadows from these lanterns, and we don't have that anymore. But, and we also don't have screen space ambient occlusion, so all of the crevices and things that used to be kind of darker, we don't get that anymore. But because we gave up some of those things, our scene now is actually running significantly faster than it did before. Now, some people asked in the comments last week, can you do some performance measurements and let us know how much faster? And yes, I will do that, but I'm planning to do that in a future video when we have several different lighting models that we can compare. So right now, we have our basic lighting, we have our tune lighting, we have our simple lighting, and we're going to actually make several more lighting models in the next couple of weeks. We're going to make a film noir lighting model, and several others like that. And then once we have a collection of them, I'm going to do some performance measurements and show you all of the stats together so we can get a good idea of how these lighting models compare with each other. Okay, that's it for the Unity portion of our video. Let's switch over to Unreal, and I'll show you a simplified and basic lighting model in that game engine as well. All right, here we are in Unreal. And the last time we worked in Unreal, we created this really cool tune shader. And you can see that we've got the different striations or divisions between the paint of the tune. That's pretty neat. But the tune shader is not a good place for us to start for our basic shader. So let's open up our content drawer here, and I'll come into my models folder, and we have this lighting model called Simple Lighting 2, just like we had in Unity. So I'm going to drag this in, and this is the one that we're actually going to be using to create our basic lighting. So I'm going to make a copy of Simple Lighting 2, and we're going to call it Basic Lighting. So I'll select this and just copy and paste it, and then we'll rename it to Basic Lighting. And let's open this up and take a look at what we have here. Okay, so we have a bunch of input values. We have color, metallic, roughness, normal, ambient occlusion. Then we're calculating reflectance, adjusting smoothness. Here are our specular highlights and our diffuse. Then we've got our ambient here, and this is our fog coming in, I think. And then we send it all out. But we want to simplify this so that we can make it run faster. Now, there are a couple of things missing in Unreal. One of the disadvantages of trying to customize the lighting in Unreal is unless we modify the source code of the engine itself, I don't have a good way of calculating lighting for additional lights or for getting shadows. So those are two main drawbacks. But we are going to go ahead and simplify this to make it as cheap as we can. So the first thing that I'm going to do is I'm going to get rid of metallic. I'm going to get rid of roughness. And we're just going to keep base color, normal, and ambient occlusion. So I don't have any smoothness, so I'm going to delete that. I'm going to delete specular blend, so we're just doing diffuse. And I'm going to delete reflectance, because that's mostly for reflections and for specular. So I can get rid of that. So we've simplified things quite a bit already. But there are a couple of things we need to do now inside each of these nodes to make things work a little bit better. Diffuse Lambert is already very simple, so we can just keep that as it is. But I do need to simplify my ambient material function here. So let's go back to our content drawer. I'll go into my ambient folder. Here's our ambient simple. I'm just going to copy and paste this, and we're going to rename this to ambient basic. So let's open up ambient basic, and we'll take a look here. And I think what I'm going to do is just delete this entire top half here. This is the ambient color that we were calculating before. And we're just going to keep this bottom half. So here's our normal coming in. And we're going to take this skylight environment sample, And instead of bringing in our roughness like we are now, I'm just going to give it a roughness value of 1. And so that's going to make our roughness just like as rough as it can possibly be. And I think if we do that, we don't need the reflection vector. So I'm going to get rid of that reflection vector calculation and just make the normal the direction that we're getting our ambient in. Now this ambient may be maybe a little bit too rough. So maybe I'll reduce the roughness just a tad. I'm taking a look at what we're getting on our render ball here and just checking to make sure that what we're seeing here will provide a good ambient. Let's see, maybe if we set this to like 0.4. I want it to have a few little details, but not too much. I think maybe 0.6 is the right value to use here. All right, so that's going to give us a nice ambient value. And we got rid of all of those other nodes. Oh, and I can also get rid of my reflectance multiplier here and just wire all of this directly out. Just like that. I do think I want to multiply it by the ambient occlusion though. So let's go ahead and add an input for ambient occlusion. And we'll make it a scalar and we'll give it a default value of 0. And then we're just going to multiply our ambient by our ambient occlusion value coming in. All right, there we go. There is our very cheap specular. Oh, I want to give our ambient occlusion a default value of 1. There we go. Okay, so there's our very cheap ambient, and we'll save this, switch back to basic lighting, and we'll bring in our ambient basic. Now we just need to connect up our ambient occlusion and our world space normal, and then we can wire out the result. Okay, so this is it for our simple lighting. I just need to combine our diffuse together with our ambient. And so what I'm going to do is just delete a bunch of these nodes that we're not using. This node here is our diffuse color. And so I'm going to take our diffuse Lambert calculation and multiply it by the color. And then we're going to add in our ambient. And then we're going to multiply all of that by our base color. And that's going to be it. So here's our base color over here. Just multiply that by the result and then wire it out. So our inputs are normal, ambient occlusion, and base color. And then we create our output. All right, so let's save this. And we'll switch back to our lighting main material. And let's bring in our lighting basic. And then we're going to connect everything up. So here is our base color. Here is our normal. And here's our ambient occlusion. Now, obviously, you could get these values from textures if you wanted to. You could create an ambient occlusion texture, normal map for the normal, and a base color texture. But we're not doing that right now. We're just using some solid values. And so our result is this very simple custom lighting model that does diffuse lighting plus our ambient. And we get some really cool results. All right, I actually did a little bit of work off camera to make this demo a little bit nicer. We're still using our same basic lighting model here, but I brought in some textures. These are my cobblestones textures. I have a base color texture, a normal map, and we're getting our ambient occlusion here from our mask map, now you can see that we're getting some pretty nice results from our basic lighting. We're not calculating any metal or we're not calculating shadows, and we're not calculating any additional lights. We're not calculating screen space ambient occlusion or reflections or specular or any of that. But we're still getting pretty decent results. And so if you needed to, in Unreal, to create a lighting model that allowed you to get like as fast as performance as possible, and you didn't mind that it didn't support things like additional light sources, so this only works with one directional light, but you would be able to calculate this lighting and get a material that just renders like really fast. So that's the advantage here, that if you're creating a project for a low-end hardware, or you have some objects that are in the background that you can afford to cut down the rendering cost on to make your project render faster, this is the way to do it. All right, that's it for today's video. Hope you enjoyed it. Come back next week. Next week, we're going to create the film noir lighting model, and that's going to be a cool one. So be sure to come back for that. And in the meantime, have a great week, everybody.